This bridge wasn't meant to fall. Reinforced arches, 48-ton blocks, and layers of mine traps made it nearly untouchable. Russian engineers believed its cascade of TNT would stop anything before it even touched the girders. But one Ukrainian drone found the single flaw, an exposed pressure plate, and planted a trigger so precise that 30 mines went off like dominoes. Within seconds, the entire central span collapsed into the river. We've seen drones strike before, but never one that turned the enemy's defenses into a weapon of mass destruction. Before we move on, please take a moment to subscribe to the channel and like the video. How does a $3,800 drone challenge a bridge reinforced to shrug off artillery shells? The question sounds absurd, like throwing a paper airplane at a bunker, but that's exactly the match Ukraine faced. The drone in question was called the Vampire, a first-person view aircraft built around a skeletal carbon fiber frame. It wasn't armored. It wasn't made to haul heavy explosives. It could only stay airborne a handful of minutes before the batteries bled out. Its biggest advantages were flexibility and low cost. The frame could slot in small cameras, lightweight warheads, or guidance modules depending on the mission. But no amount of modular design changed the math. Across the river stood a structure engineered to last decades, weighing more than tanks stacked end-to-end, protected by overlapping Russian fortifications. The Vampire couldn't punch through it directly, but that wasn't what it was asked to do. The bridge was more than concrete and steel. It was wrapped by defenses that made the sky itself dangerous. Russian crews strung wire mesh and nets above the spans like invisible walls, intended to snag drones before they closed on target. Below, machine gun crews sat in nests that overlooked both approaches, weapons dialed to fire on cues from spotters. Any drone operator working at 5.8 gigahertz, the standard band used for most FPV craft, hit yet another invisible barrier. Russian jamming arrays drowned out the signal with electronic static, leaving pilots blind. These weren't improvised measures. They were layers in a system carved out during months of planning, and on paper, they should have forced the Ukrainian craft to fall helplessly into the water. But the Russians had buried more than just obstacles into the structure. Hidden within the bridge were 30 TM-62 anti-tank mines, each with enough explosive to rip through armor weighing dozens of tons. These were built in as a trap, meant to erase any attempt at forcing vehicles across. The idea was simple. If Ukrainian convoys tried to roll over, the bridge would kill them before they reached the midpoint. What Russian engineers did not consider was that those same mines could be turned from shield to weapon. Instead of keeping the bridge safe, they had filled its skeleton with fuses waiting to be hit. Like booby-trapped bones, the explosives lined the load-bearing parts of the span, making every stone above them rest on a sleeping charge. The weight above was not symbolic. 48 tons of reinforced slabs sat locked in place across the water, each section engineered to hold convoys of trucks and armor. To topple something of that size would normally require airstrikes or guided missiles. The Russians believed their mine barrier would destroy any outsider long before it could threaten the girders. The flaw was not in the protection itself. It was in forgetting that explosives, once set, can be turned from a defensive wall into a sword. For the Ukrainians, the first fight wasn't against concrete. It was against static. Every FPV pilot knew what happened when 5.8 gigahertz met Russian jammers. Controls cut out, visuals black, and the drone spent its final seconds tumbling. Engineers inside Ukraine's drone teams searched the frequency spectrum for an answer. They shifted to a 900 megahertz link, slower but far tougher to erase. That lower band cut through the haze, kept video feeds alive, and handed operators the chance to maneuver right near the girders. It wasn't complete immunity, but it gave survival odds where before there were none. So when the Vampire lifted off and hummed toward the river, it wasn't just approaching concrete beams. It was heading into Russia's own engineered labyrinth, where every defense could also become a trigger. The question now became whether one small drone could flip the meaning of that design and set in motion something Russia never expected. Why would you risk hauling heavy bombs to take out a bridge when you can make the enemy's own explosives do the work for you? That was the calculation Ukrainian planners made when they looked at how Russian engineers had rigged the span. The TM-62 mines weren't simply buried at random. They had been wired together in a cascade, designed so that if one detonated, it would set off the next, and then the next, like a string of firecrackers along the backbone of the structure. To Russians, this wiring was a shield. To Ukrainians, it looked more like a switchboard, waiting for the smallest signal. The challenge, however, wasn't spotting the vulnerability. It was finding a way to hit it with absolute precision. Each mine was connected through a network of pressure plates and ignition lines. Striking the wrong point or angling in clumsily could fail to trigger the chain or, worse, detonate a mine out of sequence, breaking the link and wasting the shot. Sending in troops was impossible under the Russian guns, and artillery fire would scatter the charges without setting them all off. That left the drone pilot with a single job: drop a tiny payload in exactly the right place, at the right force, with no second attempt. The tool designed for this was almost absurd in its simplicity. Engineers shaped a cone of plasticine around a small charge. The soft body directed the explosive force downward with surprising accuracy, while cushioning the drop to avoid bouncing. It wasn't fancy engineering pulled from a laboratory, it was field ingenuity applied with surgical care. That cone became the fingertip needed to press the bridge's first switch. The weight of the drone's cargo seemed comically small for the task at hand. At one point, 8 kilograms, the warhead carried by the Vampire was lighter than a household fire extinguisher. On its own, it could scar one patch of steel or crack stone along an edge. It could never crush a span designed to transport loads of 30-ton armor. Yet the operators knew that they didn't need to bring the bridge down themselves. They only needed that small charge to wake the first mine. The Russians had armed their trap in a way that made it deadly to their enemies, but also incredibly fragile. Each mine in the chain was tuned to ignite half a second after the blast before it. That delay was brief enough to carry the shock down the line, but long enough to spread the pressure across the whole bridge. Once the first mine went off, the rest would fire in a controlled sequence with no way to stop it. In practice, it was less a minefield and more a programmed detonation, ready for whoever had the nerve to tap the start button. In the minutes that followed, reconnaissance confirmed every vehicle route across the river had to be rerouted. Fuel convoys idled, ammunition shipments delayed, and engineers scrambled to improvise crossings. The Ukrainians hadn't needed missiles or bombers. With a few $1,000s worth of equipment, they had shown that low-cost precision could twist the enemy's most carefully built defenses into their own undoing. And that single act revealed something larger than a broken bridge. It showed how a battlefield could be reshaped not by bigger firepower, but by turning hidden flaws against the one who laid them. One small drone flipped the meaning of power, not by carrying massive bombs or heavy payloads, but by turning a Russian bridge's own defenses into its downfall. That moment showed how precision and ingenuity can outweigh size. Wars aren't always won by who builds the bigger machine. They're shaped by who sees the hidden weakness first. So, what other weapons of war, designed to intimidate, hide flaws waiting to be triggered? Think about tanks, air defenses, or even ships. The future of conflict may not be written by fortresses of steel, but by the smallest machines slipping through cracks.